Here's an example I made up of adding rational expressions. So here they are, 3x minus 6 over 3x plus 3 plus x minus 2 over x plus 2. So one thing you should do anytime you're working with rational expressions, or really with anything, is think about simplifying first. So on this rational expression on the left, I see that everything has a factor of 3, so we can factor out 3 times x minus 2 over 3 times x plus 1. Okay, the rational expression on the right isn't going to change, so x minus 2 over x plus 2. But then on the left, we can cancel these 3's. Okay, good. So that's going to make things a little bit simpler as we do the rest of this. Now, we need to add these rational expressions, but they don't have a common denominator. So we need to arrange for them to have a common denominator. So let's look for our least common denominator. We need an x plus 1 for the denominator on the left. For the denominator on the right, we need an x plus 3. So this is the lowest common denominator we can get away with, x plus 1 times x plus 3. So let's arrange to make this common denominator appear. The way we do that is to multiply on the right-hand rational expression. The missing part of the denominator we want is x plus 1. So let's multiply numerator and denominator by x plus 1. And on the left-hand rational expression, the missing part of the common denominator is x plus 3. So let's multiply by x plus 3 in the numerator and denominator. I didn't leave myself a ton of room here. Okay. Now, the denominator for each of these is what we wanted. That is to say, x plus 3 times x plus 1. Okay, the numerator on the left-hand side, we will need to multiply this all out because we're going to combine like terms as soon as we add everything. So let's multiply this out. X plus 3 times x minus 2, that's x squared, plus 3x minus 2x is plus x minus 6. Okay, plus, now the denominator on the right is, again, x plus 3 times x plus 1. And in the numerator, again, we'll need to multiply this all out. So we get x squared minus 2x plus x is minus x. And then minus 2 times 1 is minus 2. Okay, now these rational expressions have a common denominator. Now we can just add them, so add their numerators. So we get x squared plus x minus 6 plus the other numerator, x squared minus x minus 2, all over the denominator that they share, which is x plus 3 times x plus 1. Oops, I see I've left out my plus 1 over here. These two denominators, they look different, but they are the same. The fact that these two factors are in opposite orders on these two denominators doesn't change the fact that these two denominators really are the same thing. So we can add the numerators. Now in the numerator, we need to combine like terms. So we have 2x squared. Let's see, a plus x and a minus x, so those are gone. And then minus 6 minus 2, so that's minus 8 altogether, all over x plus 3 times x plus 1. Okay, now we should think about if we can simplify this rational expression at all. And we can check if this simplifies by just factoring everything and seeing if anything cancels. So in the numerator, let's see, we can factor out a 2, so that's going to leave x squared minus 4. In the denominator, it's already factored, so we can just leave it alone. X plus 3 times x plus 1. Okay, now the numerator, we aren't done factoring it. This x squared minus 4, that's a difference of squares, so that factors. That's x plus 2 times x minus 2. And of course the denominator is still the same, x plus 3 times x minus 1. And now we can check, are there any common factors in the numerator and denominator that cancel? Well, there aren't, and so this is done. If I had cooked this example up specially, maybe some of these would cancel, but it turns out when you randomly pick numbers, they almost never cancel when you get to the end.